Let's go through this. Actually, you know what? We went up through number 7. We talked a lot in the last class. Sorry. We went up to number 7 in the last class. So let's start with number 8. Now, actually, 4, 5, 6, and 7, we kind of talked about how to set it up. We didn't actually do the solving, but it's really not that hard. Just a brief overview here, just real quick. If you wanted to solve for x, this is a parallelogram. So what do you do with these two right here? What's true about this angle here to 90? 180, right. They add up to 180, okay? So add them up, set them equal to 180. Then you can find x, and then that's all you got to do, right? Pretty easy. What about this? This is a parallelogram. It says for each parallelogram. What's true about these two sides right here? On a parallelogram, the opposite sides are what? Just take a wild guess. Come on. Yeah, but that's knowing that they're parallel is not going to help you solve for the length. Find a. What would you normally do if you run out of options? What would you usually do? You'd set them equal to each other. Okay, the opposite sides of a parallelogram are equal to each other, so you set them equal and you solve for a. Set these two equal and you solve for b. This is basically what I just went over in the other class. All right, and same thing with 6 and 7. So I didn't do all the work, but you can do that yourself. All right, let's drop down to number 8. So number 8, it says tell whether, is this the same test I gave you? Yeah, it is. Or no. You're like your original test. Because I thought the original test. Is it? Okay. All right. Because maybe that was the other test I was thinking of, like the honors class. Because I put a line here and here in the other test. So anyway, is this a parallelogram? Yeah, because if I have one pair of opposite sides, if all it was just equal to each other, I couldn't say it was a parallelogram. If all they were parallel to each other, I couldn't say it's a parallelogram. But if it's both, if it's parallel and equal, if the opposite sides are both parallel and equal to each other, then it's a parallelogram. So the question says determine whether it's a parallelogram. So what would my answer for this be? It'd be what? It'd be yes, it's a parallelogram. Okay, that would be my answer right there. Yes, it's a parallelogram. What about this? Is this a parallelogram? Well, what's true about the opposite angles on a parallelogram? They're equal. Are they equal to each other? Are these two equal to each other? Yeah. So is this a parallelogram? Yes, it is. All right. It's pretty easy, isn't it? So number 10. This is a rectangle. Now we know something. Let's go back up to this. On this one, this is a parallelogram, and these were diagonals. The diagonals of a parallelogram bisect each other. Okay, that's one of our theorems. That means that this segment and this segment are equal to each other. So you would set them equal, solve for x, correct? And that means also that this and this are equal to each other. Does that mean that this diagonal right here is equal to this diagonal right here, though? No, because look, this one looks quite a bit longer, doesn't it? Everybody watching me? From here to here, this one looks quite a bit longer than this one does right here. So they're not necessarily equal to each other until you get to a rectangle. What's true about the diagonals of a rectangle? They're equal to each other, exactly right. So RT is going to equal US. Everybody follow me on that? Okay. They also bisect each other, right? Because it's a parallelogram. So they're equal to each other and they bisect each other. So what does that mean? That means RT is equal to US, and they're both being bisected. So that means that this one, this one, this one, and this one are all equal to each other. All right, they're exactly the same. So let's see if that helps us solve number 10. So let's take a look at it. It says UZ, over here UZ, that's this little segment right there, and ZS, that segment right there. Okay, tells you what both of them are. So what do you think I'm going to do? What's true about this segment right here and this segment right here? They're equal. So what are you going to do with this x plus 21 and this 3x minus 15? You're going to set them equal. So let's do that. So 3x minus 15 equals x plus 21. Let's keep this in frame here. And then you just solve for x. Let's do it quickly. Subtract x from both sides, you get 2x. Add a 15 to both sides, and you get, what's that, 36? Divide both sides by 2, and you get 18. So x is 18. But is that my answer, though? No, it doesn't say solve for x. What does it say to find? Find US. So US is what? This whole thing right there, isn't it? So how in the world am I going to find that whole thing? Well, I can find uz, can I? Okay, uz is what? X plus 21. Well, I just found what x is. So what's uz? 18 plus what? 21, which is what? 39? Okay, so uz is 39. Without doing any other math at all, what's zs equal to? It's got to be 39 as well, because remember we said they're equal to each other. So what do we do to find us? Add them up. 39 and 39. What's that? 78? So us is equal to 78. Anybody have the original test that I gave you? Okay, just make sure my answers are right. I'm not doing anything wrong. Okay, because I don't have the answer sheet in front of me. Just want to make sure I don't make a silly mistake, because I've been known to do that. All right, let's get out of this purple. Let's go blue here. Let's see, will this blue show up? Yeah, this shows up pretty good. All right, let's talk about the angles. Now, let's do this. Might as well just get rid of all this mess. There we go. Clean it up a little bit. Now we'll go back to the blue. All right, it says angle SUT. Let's find SUT. Let's mark it. That would be that angle right there. It's 3x plus 6. And that angle RUS, let's find that one. RUS, that would be this one right here. And that's 5x minus 4. The question says find SUT. Well, first of all, we're going to have to find x, aren't we? So do we set them equal to each other just like we did the other thing? No. These two aren't necessarily equal to each other. But remember, this is a rectangle. So what do these two angles do? What's the relationship? Ivy, you see it, don't you? You don't see it? Oh, I thought you were ready to answer. I thought you were ready to pounce. I was giving you a chance. All right, Brianna, you see it. What is it? 90 degrees, right. These two angles, it's a rectangle, isn't it? So that must be a 90-degree angle. So what's true about this one arc angle and this two arc angle? They have to do what? They have to add up to 90 degrees. Does everybody see that? Don't just automatically set stuff equal to each other all the time. You got to see the relationship. So these two add up to 90. So 3x plus 6 plus 5x minus 4, that equals 90 degrees. They add up to equal 90 degrees. So let's do the math. 3x and 5x is 8x. Positive 6 and negative 4 is positive 2. And that equals 90. It's a weird 9. Subtract 2. 8x equals 88. And then divide by 8x equals 11. Is that what they're asking for, though? Did they ask for x? No. They asked for angle SUT. So here's angle SUT right here, isn't it? So what are we going to do with that 11? Going to plug it back in, right. So 3 times 11 plus 6. 3 times 11 is 33. 33 plus 6 is what? 39. So that's what angle SUT is equal to, 39 degrees. So there's a few steps you had to think about there, but the math wasn't hard, was it? It's just you had to realize that the relationship between those two angles, they added up to 90 degrees. That was the key to that problem. All right, so you added them up, set them equal to 90, you did your algebra, but then you had to realize that you take that 11 for x and you got to plug it in for angle SUT. So you plug it in right there, and then you do the work and you get 39. All right, I mean, that's a classic geometry problem right there. I mean, that's kind of what we've been doing all year long, isn't it? You take a relationship, you either set things equal to each other, you add them up, set them equal to 90, or you add them up, set them equal to 180, or whatever, and then you got to plug it back in. We've been doing that all year long. All right, let's keep going. When are we out of here? This is 5th period, 1:40. I got 15 minutes, okay. This is a rectangle as well. Let's make this a little bit bigger so we can see it. Here we go. It says this quadrilateral is a rectangle. Find the measure if angle 1 is 40 degrees. So this angle right there is 40 degrees. And we need to find angle 2. Well, look, we basically just did this, didn't we? What's true about angle 1 and angle 2? Are they necessarily equal to each other? No. What are they? They're add up to 90 degrees. So if angle 1 is 40, what's angle 2 going to be? 50, right. 90 what? Minus 40. That's 50 degrees. So angle 2 is 50 degrees. Pretty easy, isn't it? It's the same exact situation as we had before. This was a little easier because we didn't have to solve for x and plug it back in. We had a regular number. You just take it away from 90 and you're done. All right, what about this angle right here? Angle 4. What is it? Okay. We have another word for it. I see what you're saying. You said it's opposite angle 1, but we have a little bit more words for that. Do you remember it? Say it. Carol, you said it. Okay, they're interior, but they're what kind of interior? They're alternate interior angles, right? And what's true about alternate interior angles? They are what? Equal. So now look, you didn't really have to know the words alternate interior angles, did you? All right, all you had to do was look at angle 1 and look at angle 4 and know that they're equal to each other. All right, but the reason is because they're alternate interior angles and they're equal. So angle 4, without doing any math at all, is 40 degrees. Simple. So 12 and 13 takes you, what, 10 seconds. 90 minus 40 is 50. That was all the work you really had to do for that. But you had to know stuff, though, right? Just because you didn't have to do real work for it, you do have to know some stuff. All right, what about this one? A rhombus. What in the world is a rhombus? What do you think? It's a quadrilateral with what's true about the sides of this? All right, nobody's talking to me today. What, are you mad at me or something? Because it's so cold in here? A rhombus, all 4 sides are equal to each other. Okay? All 4 sides are equal to each other if it's a rhombus. So let's put some stuff in here. RK is 5, so we'll put a 5 right there. RY is 13. That's this one up there. Angle YRZ is 65. YRZ. Ooh, that's this one right here. It's a little small. Sorry. But you can write it yourself. Okay, so that angle right there is 65 degrees. And what do we have to find? We have to find KY. Where's KY? Right here. We need to find this length right there. Well, here's something you need to know. On a rhombus, the diagonals of a rhombus, we know they bisect each other because it's a parallelogram. They do something else, though. They form what? 90-degree angle. Okay, they are perpendicular. Okay, the diagonals of a rhombus are perpendicular, so they form a 90-degree angle. So this looks kind of messy in here. Let's kind of redraw it just a little bit. Let's do this. RK would be right there. Then this one goes about like that. Then the RY kind of goes like that. Kind of. It's a little more slanty than that, but you get the idea, don't you? That looks a little cleaner there, doesn't it? So what's that? 13, and this was 5. And what are they asking for? KY, which is this one right here. Everybody see that? Let's just call it X. Is that all right? So this is what we want to find. So what would you do if you know this is 5, you know this is 13, and look what you have. You got a right triangle, don't you? How would I find this X right here? Got a right triangle. I know 2 sides of a right triangle. Say it. Pythagorean Theorem. That's right. Pythagorean Theorem. You guys with me today? Okay. All right. So you do Pythagorean Theorem. Or you could do another thing. This is something that we learned that can be really, really helpful. Do you remember learning the Pythagorean Triples? Do you remember that? 3, 4, 5 triangle. Right? We've talked about that a lot, haven't we? There was another Pythagorean triple. Do you remember what it was? 5, 12, 13. Now look, and you probably, when I did those Pythagorean triple things, you probably thought, oh, why bother learning those? That's dumb, because I can always do Pythagorean Theorem. But look, it's not so dumb because you can do this a lot easier knowing that this is what? A 5, what? 12, 13 triangle. It's one of my special Pythagorean triples. And then that saves me from doing the work of Pythagorean Theorem. So was it that dumb knowing your Pythagorean triples? No, it was pretty smart to know that because it saved me work. Anytime I save some work, I think that's a smart thing, don't you? Yeah. All right, so that's 12. Or you could do Pythagorean Theorem. How would you do Pythagorean Theorem? You would, you go 5 squared plus x squared equals, that's a weird squared, there we go, equals what? 13 squared. All right, so x squared equals, now I'll just do this, you can do this on a calculator if you wanted to, but 13 squared is 169. This is 5 squared, which is 25. You subtract 25 from both sides. So x squared is going to give you, if you subtract that, that's 144. How do you get x? Square root both sides. What's the square root of 144? It's just 12. So there it is, just like I said. But look, I saved all that work by knowing my Pythagorean triple. Right? You guys don't seem very impressed with that Pythagorean triple thing. I thought you would say, oh man, yeah, if I would have known that, that would have saved me a lot of work. You don't feel like that? No? All right. You guys are bringing me down. There's like a end of the year vibe in here. I wonder why, because there's only one more day left, isn't there? All right, so come on, let's get a little more juiced up. All right, because I'm basically giving you all the answers. Well, you know, all the problems, the type of problems anyway, they're going to be on the test. You should be so grateful for this, and it doesn't seem like you are. That's okay. Let's do this. This is a trapezoid. What's that? I skipped 15. I sure did. Didn't do the angle, did we? YZR. Where's YZR? That would be this angle right there. Okay. Let's see. We said this was 65, right? Oh, look at this. Let me make this a little bit thicker. Watch this. I see something that you may not have seen, but it's going to make things a little easier for us. A couple ways you could do this, but I saw this when I showed my honors class yesterday, and I think this is a good way to do it. See that triangle I just made in orange right there? Tell me something about that triangle. It's isosceles, isn't it? It's not equalateral because we don't know that this side is equal to this side. But we do know that these two sides are equal to each other. So it's isosceles. What do we know about the angles on an isosceles triangle? The opposite angles are what to each other? They're equal to each other, okay? The opposite angles of these equal sides are equal. So I already knew what this angle was. I knew this was 65, so guess what? This is what? 65 without doing any math at all. Isn't that nice when you don't have to do any work with it? You just look at it and realize what it is, and that's what we have right there. All right, let's go to the trapezoid. That's kind of an ugly orange, isn't it? What haven't we gone to? Let's go with this red. All right, let's do this trapezoid right here. It says T and S are midpoints of the legs, so that means that is a midpoint, so those two segments are equal. This is a midpoint, so those two segments are equal. We call that a mid-segment. Do you remember using that word before with trapezoids? We call that a mid-segment, TS. What do we know about the mid-segment? Do you remember relationship with this stuff? No? It's kind of like the average of the two bases. So if I take the top base and the bottom base and add them together and divide by 2, I'm going to get this middle segment right here, this mid segment. All right, so let's put some numbers in. HJ is 8, so that's 8. LK is 14, and we are trying to find TS, this one right here. So how do we do it? Remember, the mid segment's the average of those two numbers. So how do you average something? You add them up. So what's 8 plus 14? 22, right? But then what do? This is not 22, is it? Because this is shorter than 14. There's no way it's 22. What do we do to that? Divide it by 2. And what's that? It's 11. Is that right in the middle of the two? Absolutely. Because look, it's 3 away from 8 and it's 3 away from 14, isn't it? So that's how you find it. It's pretty easy. It's just the average of the two bases. If you think of it that way, it's a really nice way to look at it. All right? Let's get rid of all that. All right, let's put some other stuff in here. Oops. What did I do? There we go. All right, what about this one? HJ is 5. All right. And TS, this time, they tell you the middle one, and they ask you to find the bottom one. Now, there's a couple ways you could do this. Let me show you the easiest way. Of course you do. So look what we're going to do. Remember the other one was 3 away from the top and 3 away from the bottom? How many is this? How many is 12 away from 5? What do I have to do to 5 to get to 12? Add what? 7. Right. So guess what? If this is the mid segment, then I have to do what to get this length? Add a 7 to that, right? Because this middle one is 7 away from the top, and it's going to also be 7 away from the bottom. So what's the bottom going to be then? 19. It's as easy as that. See that? Because it's the average. It's the one in the middle, right? The 12 is 7 away from this one, 7 away from this. And that's the easiest way to do it. I'm giving you good stuff here. You guys are acting like I'm killing you. I mean, I don't know how you should be acting. I don't think you should be jumping up and down, all thrilled to death. But I mean, but I'm getting sighs. That's what kills me. I'm getting like, and I'm giving away stuff, man. I'm giving you good stuff here. What's that? 7 plus 5 is 12. Because 7 is 2 more than 5, right? If I put 7 up, I got 5 and a 2, right? So it's 12. All right, what about this one? JS is 5. JS. Oh, that's one right there. Oh, now we're talking about these ones along the side. And it says find JK. My goodness, this is so easy. Watch. Remember what I said about S? S is a what? Well, it's a midpoint. Point S is a midpoint, right? So JS is 5. What else is 5? SK. But that's not what they ask for, is it? What do they ask for? They ask for JK, which is the whole entire thing. So what's the whole entire thing? It's 10. It's as easy as that. Everybody with me? All right. Those weren't so hard, were they? Once you know the information, right? You got to know the stuff. But the math was pretty easy. All right. Everybody all right? Okay. Just checking. Seems like something's going on. Don't know what it is, but I'll keep going on. And we'll finish this up. We got like 2 more minutes. It says this thing is a kite. It says RJ is 3. Where's RJ? That right there is 3. It's a weird looking 3. Let's try that again. And then RK is 4. Right there. Find JK. JK is this one. I'll call it X. Is that all right? Now, what do we know about the diagonals of a kite or a rhombus? They're perpendicular. Okay, so that's really important right there. So if this is 3 and this is 4, Pythagorean triple, don't even do Pythagorean theorem. 3, 4, what? I've already written it down once today. You got to remember it. 3, 4, 5. It goes right in order, right? There's no way you can't remember that. 3, 4, what? 5. That's it. That's how you find JK. Now, I could have put some weird numbers in there, but I made it easy for you by putting 3 and 4, because that gives you the Pythagorean triple of 3, 4, 5. One more and we're finished, right on time. GHJ, that's this angle right there, is 80 degrees. I'll put a little arrow. And then GKJ, where's that? GKJ, that would be this one right here, is 40 degrees. So that angle is 40 degrees. What is HGK? HGK. This one right here. Watch, real quick. This big angle G and this big angle J are equal to each other. What's 40 and 80? It's 120. So these two, what do all 4 of those big angles add up to be? No, 360. So 360 minus 120 is 240. But are these angles 240? No, they're both exactly the same. So what do you do with that? Divided by 2, and it's 120. So that angle right there is 120. That's it. HGK. Yep, that's the right one.
If I could please ask the following.